Hello everyone, I welcome you all for today's session. So in today's session we'll be dealing with module number 2, analysis of stress and strain. Right. So in module number 1 we have studied uniaxial loading, that is we have found out stresses which were caused because of loading in one direction only. Now in this module mostly we'll be dealing with bidirectional stresses, right? So let us know what are bidirectional stresses, how they are caused, right? How to calculate them. So let us start with the today's video lecture. So first let me start with types of axial loading. Types of axial loading. Axial loading. So it is divided into three types. It is divided into three types. First one is uniaxial loading. Second one is biaxial loading, and third one is triaxial loading. Right, so uniaxial loading is nothing but it is loading in one direction only. So it is the simplest of all the three. Right, so let me say it is sigma x, that is loading is in x direction only. Next, I'll take the case of a bidirectional loading. In this case loading will be in two direction. Let me say it is sigma x and sigma y. Then in triaxial loading we need to consider a three-dimensional element. Because we are having loading in three directions, right? So this is sigma x, on the other side also it is sigma x, this side it is sigma y, and this side it will be sigma z, right? On both the sides it will be sigma z. So this is triaxial loading. Now about this we have studied in module number 1. Mostly in module 2 we will be concentrating on the second type of stress. So let me tell you in detail regarding biaxial stresses. Right, so the example of biaxial stresses are LPG cylinder, gas filled balloons, etc. Right, so LPG cylinder. Now let us know why I am calling LPG cylinder as a biaxial state of stress. Right, so let me draw it for you. Right, your LPG cylinder will be something of this type, similar in shape. Right, now it will be having a gas inside, so that gas will be at some pressure, P. Now this gas which is present inside the LPG cylinder, it will be causing this pressure P such that the pressure P will be acting perpendicular to the contact surface. Pressure P will be acting perpendicular to the contact surface. Right, so this curved body is the contact surface and the pressure of the gas will be acting perpendicular to the inside the cylinder. Now what happens if you increase this pressure P? When you increase the pressure P, when you increase the pressure P, two things are observed. Diameter increases, so that is the first thing, and second thing is length will increase, right? So what I'm trying to tell you is, whenever this pressure P is increased, this cylinder will try to increase in diameter, as well as it will try to increase in length, right? It will try to increase in this direction, also it will try to increase in this direction. Why? Because the loading, because of the pressure, will be in this direction as well as in this direction. So this case where the loading is in two directions, one is this one and another is this one, you can call it as X and Y, or you can call it as circumferential and along the axis of symmetry, right? So since the loading is in two directions, this becomes a state of a biaxial stress. Now let us go for a case where for all these three cases, we are going to check out what are the stresses on an oblique plane, right? Here the loading is along the longitudinal axis. Even in oblique plane the loading will be there itself, but I am going to consider a plane at certain angle with respect to the longitudinal axis. So let us study that in detail, right? So first I will consider the case of uniaxial loading, right? Now let me consider a prismatic bar. Whose cross section is circular in nature. It is subjected to a force P, because of which the stress sigma x is developed in this, right? I told you prismatic bar is a bar whose diameter remains constant from one end to the other end. So in this case stress is given by sigma x is equal to P by A. Now I'll consider the same case of the prismatic bar, which is subjected to same force P on either sides. But now I am interested in finding some forces or the stresses which are coming on this oblique plane what I have considered. So this oblique plane is making certain angle theta with respect to the longitudinal axis, right? Which is the longitudinal axis? So these two line of action of forces, if I connect it together, whatever axis is formed, so that I call it as longitudinal axis. Now in this case, if you just check out which all are the forces coming on the oblique plane, you will see to it that there will be forces in two direction. So one will be the normal direction, so in normal direction you will be having the normal force, and second one will be in this direction, that is along the oblique plane, so that will be PT, right? PT stands for tangential force. It is behaving like a tangent, or it is coming along the oblique plane, so I am calling it as tangential force. Now these two forces gives rise to stresses once again, and those two stresses I call them as, here it is shear stress because it is tangential to the oblique plane, and here it gives rise to sigma n because it is perpendicular or normal to the oblique plane, right? So These two are important stresses which are coming in oblique plane in case of uniaxial stresses. The same thing holds good for biaxial stresses as well. So mostly in this module we are going to study how we are going to calculate these stresses sigma n and tau, right? So let me consider the same case for a biaxial stress, biaxial loading, biaxial loading, right? Now I'll consider a biaxial element. Okay, so for a biaxial element, you know, loading will be in two directions. So here you are having px, which gives rise to sigma x, right? This direction it is sigma x. Along the y direction I am having py, which gives rise to sigma y. So this is also sigma y, right? Now here also I'll take an oblique plane. Here also I'll take an oblique plane at some angle with respect to the longitudinal axis. Now even if here, if I am going to check what are the forces coming on the oblique plane, I observe that the forces will be in two directions. Which are those? One is the normal direction and second one is the tangential direction, right? In normal direction, once again it is Pn and here it is Pt, and similarly it gives rise to sigma n and here it is shear stress, right? Now this continues and it is similar for triaxial stresses also, right? So here let us know what are these sigma n and tau. Sigma n is normal stress on oblique plane, normal stress on oblique plane, and tau is shear stress on oblique plane, shear stress on oblique plane. Proceeding further, let us study about principal stress and principal strain, right? So let us study about principal stress and principal strain. So I'll take the heading as principal stress and principal strain. Principal stress and principal strain. Okay, so in order to explain you what is principal stress and what is principal strain, first we should know what is a principal plane. So let us understand what is a principal plane. In order to understand what is a principal plane, I take a biaxial element into consideration. So it is sigma x on both the sides. So in this side it is sigma y, right? Once again I consider a case of an oblique plane. Now it is in this direction. Let us say it is making an angle. Theta, right? Now I already know that if I want to check out the forces which are coming on this particular oblique plane, so I'll be getting two forces which are sigma n and tau. One will be in normal direction, other will be in tangential direction. Now important point to be noted here is the value of sigma n and tau. The value of sigma n and tau will vary with the value of theta, right? So that is the first point. The value of sigma n and tau will vary with the value of theta. Similarly, the second point, it will vary value of sigma n and tau will vary with the value of area of the oblique plane. Area of the oblique plane. Right? So for different values of theta and for different values of this area, I will be getting different values of sigma n and tau. Right? Now there will be one such plane, please note my words, there will be one such plane for which shear stress value, there will be one such plane for which shear stress value will be 0, and that plane I call it as principal plane. Right? So the definition of principal plane is, an oblique plane on which shear stress is 0. Shear stress is 0 is called as principal plane. Is called as principal plane. Right? So an oblique plane on which shear stress value is 0, that I call it as a principal plane. So that is the definition of a principal plane. Now it is observed that there are two mutually perpendicular principal plane. Right? So there are two mutually perpendicular principal planes. Right? So there are two mutually perpendicular principal planes. Now the normal stress acting on the principal plane, now this is important, normal stress acting on the principal plane, is called as principal stress. Right? Normal stress acting on this principal plane, I call it as principal stress. Now this principal stress is located at a certain angle. This principal stress which is coming on principal plane is located at certain angle theta. Right? It is located at certain angle theta. Now therefore I call theta to the subscript p. Theta to the subscript p is the location of principal plane. Right? So you locate the principal plane and you find out the normal stress on that, it will give you principal stress, and the corresponding strain caused is nothing but principal strain. So since we are knowing that there are two mutually perpendicular principal planes, we are aware that there are two mutually perpendicular principal planes, so that gives rise to two types of principal stresses. Which are those? One is major principal stress, and second one is minor principal stress. Right? So these two come on two planes. these two come on two planes. I told you there are two mutually perpendicular principal planes. So one is called as major principal plane, major principal plane, and second one is known as minor principal plane, minor principal plane. Right, the stresses which are coming on these two are called as major principal stress and minor principal stress. Right, so that's it for today's session. Have a good day, take care, bye bye.